All right, so we are told that water is flowing through a pipe, and we're given the diameter of the pipe, and it's at a speed of 3 meters per second. What is the speed of the water when it flows into a section of the pipe that has a diameter of 2 centimeters? Right, so it's a V1A1 equals V2A2 problem, right? And of course, the pipe is narrower, right? The pipe is smaller than it was before, so we're going to expect the velocity to increase, right? If you make the same amount of water flow through a narrower pipe, it's going to have to speed up, right? So it's not going to be 3. And interestingly enough, it's also not going to be 6, right? The speed is not just going to double because we're dealing with a diameter here, right? And of course, the area of a pipe is pi r squared, right? Or the area of a circle is pi r squared. And so if our diameter or our radius doubles, then our cross-sectional area is actually going to increase fourfold, right? So we can kind of see this as pi, and then let's do half of this. So 2 squared, right, is going to be equal to 4 pi. But now when the diameter changes to 2 and the radius changes to 1, pi times 1 squared is going to be equal to 1 pi, right? So again, because of this squared, the change in diameter is going to result in a change in area that is fourfold, right? So diameter is half, area is 1/4. And the way that I like to do something like this is I like to do 3, and then we'll say the area is 1 for this one, for A1, equal to V2, and then area 2 is 0.25, right? So area 2 is 1/4 of area 1. Now you could obviously calculate the area itself, but that involves pi, and that gets a little bit annoying. So I can kind of just plug in the numbers that I want. I plugged in 1, and then I plugged in 1/4, right? You could also do 4 and 1, which would probably make the math easier, right? And in fact, let's go ahead and do that, right? 4 and 1. Because really what matters is the ratio. And so 3 times 4 is 12, so 12 equals V2. And so the correct answer here is going to be C. And I hope my method of solving it made sense. A bit of a strange or perhaps unintuitive method, but it really just requires you to understand that area 2 is really 1/4 of area 1, and therefore velocity 2 is going to have to be 4 times velocity 1. So the correct answer here is going to be C.